I am Ian Andre Fabrania, and today I will be discussing how the internet works and visual history of the web. Before we proceed, let us have the introduction first. What is internet? Internet is a system architecture that has revolutionized mass communication, mass media, and commerce by allowing various computer networks around the world to interconnect. The internet, sometimes simply called the net, is a worldwide system of interconnected computers and networks and electronic devices that communicate with each other using an established set of protocols. Now, let's proceed to how the internet works. It works by using a technique called packet switching and by relying on a standardized network protocols that all computers can interpret. The internet operates by breaking data into packets which travel from the source server to your device through various network paths. According to this website, this is how packet switching works. The message is divided into packets or fixed or variable sizes. Each packet contains a header with a source and destination address. So yung packet daw is dinidivide into smaller pieces. And each pieces is may katumbas siya na header and the end destination address. Next, the packets are sent through the network independently and can take different routes to the destination. So yung mga na-divide na packets, pinapadala na sila sa network independently and pwede po sila dumaan sa iba't ibang route as long as it leads to their destination. Next, packets are buffered and queued along the road to prevent network congestion. Next, packets arrive at the destination and are reassembled into original message using the headers. So, this fourth step, it shows the purpose of the header that I've mentioned earlier. So, pagdating ng packets sa destination, ina-assemble sila ulit into original message through the header. Then lastly, acknowledgements are sent back to the source upon safe receipt of packets. Next is internet protocols. To retrieve the required data on the internet, a set of guidelines and procedures known as protocols must be adhered to as they guarantee accurate and effective data transmission. So these internet protocols is like a law on the internet. This guarantee an effective and accurate data transmission. Now, let's proceed to the components of the internet. There are different components of the internet, and these are client or endpoint devices, servers, internet protocols, IP addresses, routers, domain name system or DNS, web browsers, internet service providers, social media platforms, and firewalls and security measures. First, let's start with client or endpoint devices. These are the multitude of interconnected components or clients that access and contribute to the internet. This can include computers, smartphones, tablets, routers, web servers, and IoT or Internet of Things devices. So these client or endpoint devices are simply talks about the phone that we are using. These are the client and endpoint devices that contributes to the internet. Next is server. Server are the computers that provide services or share stored resources with the client devices. Their main job is to comply with client requests by providing the requested information or performing the requested task. Next is internet protocols. To retrieve the required data on the internet, a set of guidelines and procedures known as protocols must be adhered to as they guarantee accurate and effective data transmission. Common internet protocols include IP, TCP, HTTP, or HTTPS, and file transfer protocol. So these internet protocols is like a law on the internet. This law ensures that the data transmission is effective and accurate. Next is IP addresses. IP addresses are used to identify devices on the internet. This can include IPv4, such as 192.196.1.1, which is the default IP addresses many router manufacturers use to access a router's interface. Next is IP addresses. IP addresses are used to identify devices on the internet. This can include IPv4, such as 192.196.1.1, which is the default IP addresses many router manufacturers use to access a router's interface. Routers forward data packets between computer networks by using routing tables. Routers determine the best routes or paths for data transfer between devices. Next is domain name system. DNS converts human-readable domain names such as www.explain.com into machine-readable IP address. It also acts as decentralized directory that helps users navigate the internet. Next is web browsers or search engines, including Apple, Safari, Google Chrome, Microsoft Edge, and Mozilla Firefox. Let users access and engage with material on the internet and also decipher and present web pages for them. So basically, these web browsers or search engines are Google, Microsoft Edge, and other web browsers on your phone, device, tablets, computer, and other devices. Next is ISP, or Internet Service Providers, are companies that provide users with internet connectivity. They operate the infrastructure, including the cables and routers needed to connect users to the global network. So basically, this internet service provider are the ones that provide us internet like PLDT, Globe at Home Wi-Fi, Field Products Wi-Fi. So basically, these are the internet service providers. Next is social media platforms. Social media platforms, we all know what this is. These are examples of these are Facebook, Instagram, TikTok, and other platforms that we use to engage with others and use for entertainment. Next is firewalls and security measures. Incoming and outgoing network traffic on the internet is monitored and controlled by different types of security firewalls and security measures. Firewalls safeguard networks and devices against unauthorized internet access, cyber threats, and malicious activities. Example of this is the CAPTCHA. When you log in your Gmail or any other account, CAPTCHA pops up, right? It asks you if you're a robot or not and gives you security questions or images to select based on what they are asking to. And this is an example of firewalls and security measures. Steps on how the internet works. First, you enter a URL into your browser. Second, your browser sends a request to your router. Your router forwards the request to your modem. Your modem turns the request into an electric signal. And fifth, the signal travels to the server that has the information you want. Sixth, the server sends a packet of information back to your modem. Seventh, and your modem turns the packet back into the internet signal. And lastly, the router forwards the packet to your computer. Now, let's proceed to the visual history of the web. The first web is Web 1.0, 1990s to early 2000s. It is also called the static web. Web 1.0, often called the static web, was the first stage of the World Wide Web. It mainly consisted of static web pages with minimal interactivity. Websites were static. It was built with HTML and displayed read-only information. No interactivity, databases, or dynamic content. Users were consumers, not contributors. So in this stage of web, it has nothing only but information which you cannot interact with, and the purpose of this web is only to be read. That's why it is called the static web. This is the example of static web. Characteristic of Web 1.0. Static pages. Websites were made with HTML and displayed the same content for all users, which means it is not dynamic. All users get the same content. Next is read-only web. Users could only consume content but couldn't interact. Example, no comments, likes, or shares, unlike today, right? Next is simple layouts. Website had a basic design, often using tables for structures. Next, limited multimedia. Images and animations were rare, and most content was text-based. So, images and videos are rare to be seen in static web pages. It is mostly text-based. Manual updates. Websites were updated manually by the webmasters. Next is no social media. There were no social networking sites like Facebook or Twitter. Lastly, use of GIFs and frames. Pages often contained animated GIFs and uses frames for navigation. Here are the technologies used in Web 1.0. HTML or Hypertext Markup Language, the basic language for structuring web pages. Next is CSS or Cascading Style Sheets, used to style web pages but was minimal. Next is HTTP, which is Hypertext Transfer Protocol, allowed communication between web browsers and servers. Next is Static Web Hosting. Next is Static Web Hosting. Websites were stored on physical servers and rarely changed. Last, File Transfer Protocol. It is used for uploading and managing website files. Examples of Web 1.0: Yahoo early version, AOL, GeoCities, Netscape, and Amazon. This is Yahoo early version. This is America Online. And this is GeoCities. It allowed users to create simple personal pages. Next is Web 2.0. It was in mid-2000s and early 2020s. This is called the interactive web. It refers to the second generation of the internet that emphasizes user-generated content, interactivity, and collaboration. Unlike Web 1.0, which was mostly static and read-only, Web 2.0 allows users to engage with content, contribute their own, and interact with others online. These are the key features of Web 2.0. User-generated content allows users to interact and share their own contents. So, earlier, in Web 1.0, it was read-only web. Users is not allowed to share their own contributions. But in this version of website, it now allows to interact and share their own contents. So users are now allowed to post whatever they want to as a contribution to the internet. Next is interactivity. Dynamic and responsive interfaces allow real-time interactions. So here, like, share, comment was created. Unlike Web 1.0, users cannot interact like, comment, or share. Next is social networking. Platforms like Facebook, Twitter, and Instagram facilitate connections and community building. Next, collaboration and sharing. Tools like Google Docs, Wikipedia, and GitHub allows users to work together. So next is rich media integration. Web 2.0 supports videos, images, and audio for a more engaging experience. So basically, this is the opposite of Web 1.0, and videos are only rare to be seen. While in this version of web, it supports videos, images, and audio for more engaging experience. So therefore, videos and images are not rarely to be seen, but it can be seen commonly on the web, which provide more engaging experience. Next is cloud computing. Many applications are hosted in the cloud, reducing the need for local installations. Next, tagging and taxonomy. Users can organize and categorize content using tags. Tagging and taxonomy talks about categorizing content using tags. So when you post online or in Facebook Reels, you use hashtags, right? These hashtags allows the users or the content creator to recommend their content based on their target audience. Next is APIs and mashups. Developers can use APIs or application programming interfaces to integrate different services like embedding Google Maps into websites. Examples of Web 2.0: social media, Facebook, Twitter, Instagram, and LinkedIn. Next, video sharing like YouTube, Vimeo, and TikTok. Next, collaborative platforms like Wikipedia, Google Docs, and Trello. Blogging and publishing, WordPress, Medium, and Tumblr. Next, lastly is e-commerce and reviews. Amazon, eBay, and Yelp. These are the technologies behind 2.0. Ajax, or asynchronous JavaScript and XML. It enables fast, dynamic pages updates without full reloads. Next is HTML5 and CSS3. Provide better design, animations, and multimedia support. So through this technology, videos and images are being supported by the web. Because this technology, it provides better design and animations and support in multimedia. Next is JavaScript and frameworks. React, Angular, Vue enhances the interactivity. Lastly is API and web services. It enables different applications to communicate. Now, let's proceed to the Web 3.0, which is called the decentralized and intelligent web. Web 3.0, often called the semantic web or the decentralized web, is the next evolution of the internet. It aims to create a smarter, more secure, and user-controlled online experience by leveraging blockchain, artificial intelligence, and decentralization. These are the key features of 3.0. Decentralization. This uses peer-to-peer blockchain networks to store data. Next, artificial intelligence and machine learning. AI helps process and analyze vast amounts of data for better personalization, automation, and smarter search results. Blockchain and smart contracts. Blockchain ensures transparency, security, and trust in transactions. Semantic web. The web will understand content contextuality rather than just keywords, artificial intelligence, and machine. Next is interoperability and connectivity. Apps and platforms will be more interoperable, meaning users can carry data and assets across different services. These are the popular technologies and platforms. Decentralized finance or DeFi, NFT marketplaces, decentralized social media, and AI-powered assistants, which is ChatGPT, Siri, and Alexa. So this is the DeFi. DeFi is a blockchain-based financial system that removes intermediaries like banks, brokers, or centralized exchanges. Instead, it uses smart contracts on blockchains, mainly Ethereum, to enable financial transactions like lending, borrowing, trading, and earning interest without relying on a traditional financial institution. Next is an NFT or non-fungible token. It's an online platform where users can buy, sell, trade, and mint NFTs. These marketplaces are powered by blockchain technology, ensuring ownership, authenticity, and security for digital assets like art, music, videos, gaming items, and virtual real estate. Next is decentralized social media or DESOC. It is a blockchain-based alternative to traditional networks like Facebook, Twitter, and Instagram. Unlike centralized platforms controlled by corporations, DESOC platforms give users controls over their data, content, and monetization, while reducing the censorship and platform dependency. Next is AI-powered assistants. These are intelligent virtual agents that use machine learning, natural language processing, and automation to perform tasks, provide recommendations, and interact with users. They are used in personal assistance, business automation, and customer service and smart home devices. So basically, these AI-powered assistants are like ChatGPT, Siri, Alexa, Copilot, and other AI assistant tools. These AI assistant tools can be used in different aspects of community. It can be used in business, economy, even in education. And the technologies behind 3.0 are blockchain and distributed ledger technology, cryptocurrency and tokenization, artificial intelligence, semantic web, decentralized identity and privacy, metaverse and extended reality, and lastly, edge computing and IoT. So those are the topics that assigned to me. Other topics will be discussed by my other group members.